Hello, welcome students. So as I told in the previous module, uh, this is the concluding module of this chapter on harmonic oscillator. Okay. So in this module, we will purely look into some of the problem which we have to solve in this chapter. Okay. So the problem solving session, in fact, we are aiming to train you to tackle the problem. Okay, how to understand the problem and how to handle the problem and how to solve till the end. Okay, so this video is purely to show you or to give you a methodology to do problems in physics. Okay, so don't think that we are dealing the whole set of problem in this module. No, absolutely no. We will simply look into some of the problem, selected problem, and which is familiarizing you with the idea of how to do or how to do away with the physics problems. Okay, so you take it as a training session and do maximum number of other problem from the textbooks. Okay, so that is the very purpose. At the same time, you can, of course, you can get familiarized with some of the problem given in the exercises. Okay, so here is the first question. A body executing simple harmonic motion has amplitude 0.8 meter and period 1.6 seconds. Okay, find its velocity and acceleration after 0.3 seconds of its departure from the extreme position. So this is the question. What is the meaning of this question? Okay, you have a pendulum, oscillating pendulum, which starts its motion from the maximum point, extreme point. Okay, extreme point means at the top point. Okay, you know that when you have the expression for simple harmonic motion, x of t is equal to a sin omega 0 t plus phi, okay, or phi is the initial phase. Suppose the motion is starting from the mean position, that means at the center, you know that phi will be 0. But here it is mentioned in the problem that Bob starts its oscillation from the extreme position, extreme here or here. Okay, so for that case, phi will be equal to pi by 2. Pi by 2. Understand? If it is starting from the mean position, phi will be 0. So here it is mentioned clearly that the motion starts from extreme, so phi will be pi by 2. Okay. And question demands you to find out velocity and acceleration. So what we will do, we will find the expression for velocity. You know, velocity can be found from x like this, omega 0 into root of a square minus x square. We have derived this equation. Or you can simply find by differentiating it. Okay, you know, velocity is dx by dt, you differentiate it, you will get some expression and you can put the values, so then you will get the velocity at any time instant. Okay, time instant, because time is given 0.3 second you have to put here, and you know, period is already given, so once period is given 1.6, so omega 0 can be easily found. Okay, so so velocity can be found. And how acceleration? Acceleration, you know that it is the second derivative of x with respect to time. So you have to differentiate the given x 2 times. When you do that, you will get it as acceleration equal to minus a omega 0 square sin omega 0 t plus phi. Again, you can put the values. Phi is given here as pi by 2. Keep in mind. So we can easily find the acceleration. Okay, you briefly write acceleration like a is equal to minus omega 0 square x. Here x value is given here. X is this. Okay, so you can easily find acceleration. A is the amplitude that is given in the problem. That is 0.8 meter. So acceleration can be also found from the given data. Okay, so or straight away from x, you can also find the displacement at the time instant 0.3. What is the displacement? This is the displacement, and this is the velocity. Okay, so hope the idea is clear. You can do it. You find the answer. Okay, I simply gave the methodology to do it. Okay, from the expression. In fact, here the x is the model. Okay, X simply tell you it's a modeling basically. You have a system oscillating pendulum. We made this mathematical model. Using the mathematical model, you can find the displacement at any time, velocity at any time, acceleration at any time, and even momentum also at any time we can easily find. Provided that you know the mass of the bob, then we can easily find momentum also at different points. Because the body is moving continuously, so it will have momentum. Okay, so it's a very good problem. So you try to do this, you get the final answer. Okay, and acceleration can be also found. I told you, but keep in mind that always the phi should be taken care of. Phi is showing the initial position. For the mean position, phi will be 0, but for the extreme position, phi will be equal to pi by 2. Pi by 2. That should be taken care of. And here is the second problem. Again, very good problem. A particle moves in the potential energy field given by this expression. You know, potential is a position dependent quantity. It is given as a mathematical equation u0 minus px plus qx square. Okay. Find the expression for the force. Calculate the force constant k. Okay. K is called a force constant. And the time period. And at what point does the force vanish? Okay, so this is a university standard question. Such questions are likely to be asked in examination. Okay, so how will you do it? You know, you have studied in your first semester that if the potential energy expression is given, you can easily find the force acting on a body. So that is given as F is equal to minus du by dx. Or in gradient form, we say that F is equal to minus grade u. Okay, and its one-dimensional form is given here. F is equal to minus du by dx. Here u is given. Okay, so u can be differentiated with respect to x. Then you will get a force. Okay, minus d by dx of the given potential. So you differentiate with respect to x. So you get simply as p minus 2qx. Okay, p minus 2qx. So we got the expression for force. So question number 1 is solved. Expression for force. Then question number 2 is calculate the force constant. Okay, you know force constant f of x is equal to minus kx. And in our present given force value, you can see what is the coefficient associated with x. Coefficient associated with x is 2q. So that simply means that force constant is 2q. Okay, so we got the answer to the second question. And what is the third question? We are asked to find out the period of the oscillation. Here force is something like a position dependent quantity, and maybe body executing some oscillation. So there may be a period. And period in standard form, you know, it is equal to 2 pi into root of m by k. In our context, k is obtained. K is equal to 2q. So obviously k can be substituted with the 2q. So you will get the expression for period of oscillation in the present force. Okay, so that is given here. And what is the next question? What will be the position of the body when its force is 0? Okay, force is explained with this equation. So at some point force can be 0. Okay, so wherever force is 0, you can equate this equation with 0. Okay, so when you equate this with 0, you just solve this equation. Just to solve this equation, you can find the value of x. So we can now say that force will be 0 when x become p by 2q. Understand? When x becomes p by 2q, force on the body becomes 0. This is a beautiful question. Okay, most probably likely to be asked in university exam. And here is the third question. Again, a beautiful question. A spring of spring constant k is mounted on a horizontal table and a solid cylinder of mass m kilogram is attached at its free end and oscillated over it with the cylinder rolling over the platform. Okay, it is shown in the graphics, and your question is find the frequency of oscillation. Okay, you can imagine this is a cylinder, it is rolling over it. Okay, rolling over it. So it carry a different type of energy, It carry potential energy, it carry kinetic energy. Kinetic energy also, rolling energy will be the rolling motion is the linear motion is also there. So in fact, such a cylinder will carry three types of energy. Understand? Because it is rolling on a frictionless surface. So we can neglect the frictional loss of energy and assume that is a simple harmonic motion with no energy loss. Understand? So under that case, the total energy you can write as equal to kinetic energy, linear kinetic energy, potential energy shown by half k square, and rotational kinetic energy shown by half I omega square. It's a very beautiful problem. Okay, you can, what you have to find? You have to find the frequency. So what we have to do? You should get a standard differential equation of the form what is called d square x by dt square plus omega 0 square x is equal to 0. So we can convert this energy into that equation. So how we will do? You can write velocity, okay, in terms of x. Velocity is equal to dx by dt. Okay, and similarly, here you have I omega square. I is called moment of inertia. We have studied in the first semester about rotational kinetic energy. So I can be found as a moment of inertia of the cylinder. Okay, that is given by a half mr square. Okay, we have derived it in the semester 1, and we have the angular velocity omega. Okay, that we know that is equal to velocity by r, and velocity is already given dx by dt. So omega can be written as 1 by r dx by dt. So we separately calculated all the ingredients required for the above equation. Okay, v is here, I is here, omega is here. So let us put all these values in the above equation. Okay, so by putting this value, we will get some differential equation. You see, velocity is put here, I is put here, and omega is also put here. Now just it is a matter of rearranging. Okay, square it, place it like that. Okay, so now we have dx by dt all square here, dx by dt all square here, and this is 1 by 4m, this is 1 by 2m. I think you can add these two together. So what we will get? We will get is 3 by 4m dx by dt all square, and the second term will be simply 1 by 2 kx square. Okay, so we got the total energy in terms of x. Okay, and you should keep in mind that total energy is a constant because we have taken a simple harmonic oscillator with energy constant. So if energy is constant, what will happen? If you differentiate this energy with the time d by dt, then that should be 0. Why? Because energy is constant. So if you take d by dt, that can be equated to 0 because total energy should be always constant, and assume that there is no friction on the table. Frictionless surface. We are moving the body to a frictionless surface. Okay, so you can now equating with 0. You can differentiate now. Okay, this equation you differentiate it. When you differentiate, you can do in a simple way. These are constant 3 by 4m, and differentiate dx by dt. So you have 2 dx by dt, d square x by dt square. Similarly, second term you can differentiate 1 by 2 kx dx by dt equal to 0. Again, dx by dt can cancel, and some other terms also can be cancelled. So we get it like this, and just rearrange. Now we have 3 by 2m d square x by dt square plus kx is equal to 0. Okay, this can be written in the standard form d square x by dt square plus 2 by 3 k by m x. Okay, and we have the standard differential equation given by this form. Okay, where we already write k by m is equal to omega 0 square. Understand? and then we write the expression for frequency. In a similar way, looking on this equation here, you can write omega 0 square is equal to 2 by 3 k by m. So naturally frequency can be easily found. Once omega 0 is obtained, frequency can be written as 1 by 2 pi into root of 2 by 3 k by m. Okay, very simple, very standard, beautiful problem. We explain in a nice way. Okay, so this is another interesting problem, and we have the fourth question. Again, a uniform spring is given. Okay, a very spring unstretched length has a force constant k. Now the spring is cut into two pieces of length L1 and L2. Okay, with the condition L1 is equal to n L2. Okay, so that means L1 is much greater than L2. That's the meaning. L2 is less, L1 is high. Where n is an integer. Okay, so that means L1 is equal to 2L2 and L1 is equal to 3L2, like that. So that means L1 is greater than L2. So what you have to do? You prove that K1 and K2 are related as K1 is equal to Kn1 plus 1 by n. K2 is equal to K into n plus 1. What is K and K means spring constant of the uncut spring, okay, original spring, and K1 and K2 are the spring constant of the pieces. Okay, we have two pieces. So how we will do it? Very simple. Suppose you apply a force on a spring. Suppose initial spring get elongated some distance. So then force can be written as K into delta L. Okay, original length is L. Suppose it elongated by some length delta L, then applied force will be equal to K into delta L. Suppose the same force is applied, means you attach some body on the original spring and segmented spring. Force is same always because we attach the same body. Understand? Force will be always mg. So you can write for the first cut spring as K1 into delta L1. Similarly, for the second piece, you can write K2 into delta L2. Okay, and for the original spring, you can write as K into delta L. Delta L is the stretch, okay, increase in length. We know that restoring force is equal to spring constant into increasing length. Okay, again it is given here. What is how L1 and L2 are related? Okay, it is related as L1 is equal to n into L2. So we can write delta L1 instead of delta L1. We can write it as n into delta L2. Okay. Similarly, delta L2 same. K is equal to delta L itself. We simply change it delta L1. Use this relation and write it like this. Again, total length. Total length you can write as delta L2 plus n delta L2. Okay, it's because this is the total length, that should be the sum of this one and this one. Obviously, it should be the sum of this one and this one. Hope this is also clear. Okay, we simply use physics. Okay, no mathematics is used here. Using physics, we wrote this equality. Okay, basic physics is that for a given force, the restoring force in all the springs are same. Restoring force is same because attached to the mass is same. Okay, then you can see in all the terms delta L2 is common. Okay, delta L2 is common in all the equations. You can cancel it. When you cancel all the delta L2, what we get? K1n is equal to K2 is equal to K into 1 plus n. Very simple. Okay, very simple. And from this equality, we can make the relations. Okay, in the question, you have given some prove that question. Okay, the first prove that is K2 is equal to K into 1 plus n. Okay, so if we proved it, you take the second and third term. We proved the first question. And the second question is K1n is equal to K into 1 plus n. So K1 is equal to K into 1 plus n by n. So this way, we could easily prove both that questions. Okay, hope the idea is clear. Okay, this is also an excellent problem. And here is the final question. This is an assignment for you. A simple pendulum has a length of 0.75 meter. The pendulum mass is displaced horizontally from its equilibrium position by a distance of 5 millimeter and then released. Calculate first one a maximum speed of the mass and second one the time it takes to reach the speed. Okay, this is a very simple question because x we have already known, and you know the motion is starting from mass is displaced horizontally from its equilibrium position by a distance of 5 millimeter. Okay, that means the starting point is the extremum position. So here 5 will be equal to pi by 2. Understand? Extremum position, the movement is starting. And you know maximum speed will be attained at the equilibrium position. So that can be easily done by, you have the velocity expression here. Velocity for finding maximum speed, but you have to do for maximum speed at that point dx by dt will be 0. Okay, velocity dv by dt will be 0. When velocity is maximum, dv by dt will be 0. You can equate this with 0, one thing, but here question is maximum speed. So by equating with dv by dt equal to 0, you will get a time. Okay, understand? Omega 0 you can easily find. Why? How? Because omega 0 can be found from this length. You know that a period of a pendulum is 2 pi into root of L by G. Okay, L is given here and G is the gravity. So using that period can be found, from period omega 0 can be found. Okay, so once you get if you equate dv by dt equal to 0, you can find the time. Once the time is got, you can replace in this equation, you can get the velocity at that time. Understand? Phi is taken as pi by 2. Okay, so after that second question is time taken. So just second question, time it takes to reach that speed. So time can be also found from this equation. Initial starting point is given here, and at the extrema position, at the equilibrium position, displacement will be 0. That means it comes to a middle point. So you can this equation can be equated to 0. So time can be easily found. Okay. So starting point is taken as a maximum point. From that point, the time taken to reach the equilibrium point is taken. So obviously you can find the value of time. Okay, so these are the problems to be discussed, and with this let us stop this one. Thank you all.